Hey, Josie with Queen My Pawn. I'm going to teach you today how to find the equation of a line, or in other words, how to describe a line on a Cartesian plane. If you've seen my video on the introduction to the Cartesian plane, you'll know that you can draw many objects on it because Cartesius, or René Descartes, drew the connection between geometry and algebra. For example, this line represents all of the points where x is equal to y. For example, 1 is equal to 1 here, 2 is equal to 2, 4 is equal to 4, x equals y, or y equals x, as we all write it. And if we have another line, like this one, well, this looks like the same line, it's just shifted up by 3. 1, 2, 3. And you'll notice something cool is that when you have the same line and you shift it up, they are parallel to each other. They'll never intersect, and they make sense. They're rising up at the same rate. They have the same slope. And the second line, you just shift it up by 3. That's called y equals x, the same thing, but you shifted it up by 3. Makes sense. So let's consider something else. What if you only had 2 points? Cartesian plane, I'll erase everything and start over. If you have something like this, then you get 2 points such as they're easily identifiable. We know that this order pair is 1, 2, and this order pair is 2, 5. Well, if you wanted to find out what this line it looks like, first you can draw it. It looks something like this. And notice that lines just keep going onward and onward. So they can go this way, and then they go the other way as well, and so on. So clearly the line looks like it's going to be y equals 3x minus 1. How did I arrive at this? Well, I see that for every one step we go to the right, we go 3 up. So it's like y equals x, but amplified. And it's amplified by 3. Because when y equals x, the line, which I'll draw in red right now, oops, every time you go 1 to the right, you'll see that you go up by 1. That makes sense because 1 equals 1, go 1 to the right, 1 up, you get 2 equals 2, and so on. 2, 2, 3, 3, 4, 4. But this time it's amplified. Now, this is the same thing as y equals 3x, but the thing is that you have to shift it down by 1. So it intercepts the y-axis at -1. In other words, it's like y equals 3x, which is the yellow line, or actually the orange line here, but it's shifted down by 1. But let's say that we don't have visuals. Then you can't clearly come up with that line by that reasoning. It's a very quick way to do it, but if you didn't have visuals and you just had the points, you got to figure out what the slope is. How many, like if we go 1 step to the right, we're going 3 steps up. That much is clear. But how can you tell that from just 2 points? Well, we know that m is just the amount of distance traveled, and m is the slope. So the slope is m, and the slope, in other words, is how much you had to climb, like the amount of effort you had to climb. So it's the second point minus the first point, the difference in points. So the second point is 5 and 2. And the first point, you just subtract. That's 2 and 1. Put a line over it. And you get 3 over 1 equals 3. So this gets a grade of 3. Literally a grade, because slope is grade as well. If you ever climb mountains, mountains can have high grades or they can have low grades. This one has a grade of 3. So we know the slope of this. And we know that a line consists of a slope and an intercept. Y equals mx plus b. We know the slope already. The slope is m. So that's y equals 3x plus b. And now you gotta plug in one of the points. Either one works. For example, let's choose 1, 2. You get, for y it's 2 equals 3, and then 1 is x plus b. Well, that's just 2 equals 3 plus b. And if we go over here to the right-hand side, over here, sorry, I shouldn't have written that 3. I'll write it in green now. The way you solve these things is to get the b by itself. And the way to do that is to cancel out the 3 by making its opposite appear. So 2 minus 3 is -1. These cancel out, and you get equals b. So b is -1. And so the answer is y equals 3x minus 1, just as I originally predicted. So that's the answer. And let's do another line. So new, don't save, Cartesian plane. Okay, this time, suppose that you have 1 point. Well, there's many lines you can make from this 1 point. A line can go this way or that way. You can't really tell unless you have another piece of information, like another point. If you have another point over here, clearly the line defines those, the 2 points define that line. But if you don't have that point, you must have a slope, because if you have a slope, it gives you a grade, and that grade must remain the same. Like in the first example, we had a grade of 3. You can't have a grade of 3 here, clearly. The grade of 3 must be like this. So if I have a point such as 5, 2, and I have a grade or slope of 7, then what is the equation of the line? Well, I know that y equals mx plus b. Let's see what we're given. We're given the grade, it's 7. And we're given a point, it's 5, 2. So plug everything in. It's very easy now. 2 equals 5, sorry, not 5, 7. 7 is the slope. And then times 5, because 5 was x, the ordered pair was 5, 2, plus b. And so you get 2 equals 35 plus b. And solving for that, you subtract 35 from each side. That cancels out. And so -33 equals b. Wow. And I mean, that makes sense. Because if you keep going downwards with a grade of 7, it's going to be worse than that. Actually, it's going to be like this. You'll eventually end up at like 33, like the way it goes, but I'm out of range there. And that's an introduction to finding lines. If you have something like parallel and perpendicular, I'll cover that in the next video. For now, all you need to know is that to find the equation of a line, you need 2 points, or 1 point and the slope. And if you can figure that out with those 2 points, you're on the right track to parallel and perpendicular lines. That's it.